Today I'm going to be covering a topic called frequency trees, and it falls under probability. Now, frequency trees are a way of representing total numbers on a tree. In a football tournament, 20 matches were played. So if we just pause there at the 20 matches, then that's what tells us that our frequency tree is going to have a total of 20. So that's where our 20 goes. It says in 8 of the matches, Team A scored the first goal. So here's first goal, here's second goal. So Team A scored the first goal. So that is where that 8 comes from in my frequency tree. Now, if 8 of the goals were scored by Team A, then what would I be able to fill in over here for my unknown for Team B? I would say 20 minus 8. So that would give me 12 matches where the team scored the first goal. Now we have our second goal and we have Team A and Team B again. In 5 of these matches, they also scored the second goal. So we're still talking about Team A. So in 5 of the matches, they also scored the second goal. So Team A scored the second goal 5 times. But now this has to total the 8 because the first goal was scored in 8 matches. So 5 for Team A, so that leaves us with 3 for Team B. Then it says Team B scored the first 2 goals in 3 of the matches. Okay, so in 3 of the matches. So that means that Team B gets a 3, but in total, this needs to total up to this 12, which means that there were 9 matches that Team A scored the second goal. A garage records the mock test results on 40 cars. Of the 40 cars tested, 15 of them are less than 5 years old. All right, so we have 40 cars. So that's where our starting point is over here. We have our 40 cars. Of the 40 cars tested, 15 of them are less than 5 years old. So here we have less than 5 years old. Here we have greater than 5 years old. 5 years old or older. So 15 of them were less than 5 years old. So we're going to put our 15 for less than 5. Now, if 15 are less than 5 and we have 40 in total, how many are 5 and older? 40 minus 15 gives me 25. Then they either pass or they fail. So we have 2 pieces of information here. We have less than 5 years, we have greater than 5 years, we have them passing or we have them failing their MOT tests. 11 of the cars under 5 years old passed. So 11 of the cars passed under 5 years. So I'm in the under 5 years part of my frequency tree. So it says that 11 of them passed. 15 of the cars were under 5 years, 11 of them passed, which means that 4 of them failed. Then it says 28 cars passed altogether. 28 passed altogether. So for that, the passing altogether, it means that these circles need to total 28. So now if I have 11 of them that passed, so 28 passed in total. So 28 passing in total means that 28 cars passed, and we need to know how many of them were less than 5 years old and how many of them were more than 5 years old. So 11 were less than 5 years old and there were 28 that passed altogether, which means that 28 minus 11 gives me 17 cars that were above 5 years old that passed. So now we can simply fill in the fail because we have 25 cars that were above 5 years old, 17 of them passed, which means that 8 of them failed. Now it says work out the probability that a car fails its MOT. So the probability of it failing would equal how many cars are there in total? There are 40 cars. How many failed? We have 4 and we have 8, which is 12. 12 out of 40 chance of it failing, which gives me 3 out of 10. Last example. 80 people with similar symptoms were tested for coronavirus using a new trial medical test. So we have 80 people with similar symptoms. So that means that we have 80 people in our frequency tree. 19 of the people showed a positive result. So now if we just quickly look at our frequency tree, we have positive result, we have negative result, and then once you have a positive or negative result, we have the virus being developed or no virus at all. So it says 19 of the people tested showed a positive result. So I'm going to go up the positive branch, and that's 19 people. So now if 19 people had a positive result, then I'm able to determine how many people had a negative result by saying 80 minus 19, which gives me 61. The virus only developed in 11 of the people who tested positive. So 11 of the people who had already tested positive, which means that I'm going to now go up the positive branch again. So now 11 people developed the virus. Then it says a total of 67 people did not develop the virus at all. So now we have 67 people did not develop the virus at all, which means that I need no virus at all to total 67. Now, in order for it to total 67, I'm first going to get how many people tested positive but then didn't get the virus, or the virus didn't develop. So 19 people tested positive, 11 developed the virus, which means that there are 8 people who had no virus. Then I know that those 2 orange circles, or the total number of people who did not develop the virus at all, needs to total 67. I already have 8, which means that 67 minus 8 gives me 59 people that tested negative and the virus didn't develop. But then how do I calculate, or how do I determine my last circle? Well, 61 people tested negative. 59 of those people had no virus, but there's a shortage of 2 people that had the virus then, because 61 minus 59 is 2. The last question says, work out the probability that a person develops the virus. So the probability of, let's say, virus. Well, how many people were there in total? There were 80 people who were tested. How many developed the virus? 11 and 2, which is 13. So the probability of the virus developing is 13 out of 80. Thank you for watching my video. I hope that it helped you.